Hey everyone, let us see how we can solve this problem. The problem statement is we are given a number and a target and we have to find all the subsequences which satisfy the given condition. The condition is minimum plus maximum element is lesser than target. So if we consider this whole subsequences 3, 5, 6 and 7, here minimum is 7, 3 and maximum is 7. So when we sum this 3 plus 7 is 10, which is greater than target. So I will not taking these subsequences. So another subsequences can be 3 and 5 also, or 3 and 6 also. So it can be any possibilities. There are so many subsequences which is 2 power n. So the first things comes in our mind while seeing the subsequences is I will go to this 3 and I will ask whether you are included in our subsequences or not. So we have two possibilities in each case. Either I should take or not. If I will take, our number will becomes, our subsequence becomes 3. And again, every time I will ask, now I will ask for the next element which is 5. Either I have to include or exclude. Either I have to include or exclude. So actually this process takes big high and gives the time limit exceed. Now let us see whether we can optimize this code or not. I hope you understand the problem statement and what is the brute force solution. Now let us go through the optimal solution which we can do. Then we are given a number 3, 5 and 6 and 7. What I will do, what if I can sort and why sorting works? First of all, let us understand. If we take this, suppose our number is 4, 5 and 9 and 9, 4 and 5. The number is same, the subsequence element are same, just the order is different. This subsequence, this number, this is our original number, let us see, and it is sorted, but this number is not sorted, unsorted. So if we generate all those subsequences, I will get this as all the subsequences. And if I generate the same uh, if I generate the subsequences for the unsorted numbers also, I will get these numbers. So if we compare, we get exactly same number of subsequences and same number for each subsequence also. Just the order here will be changed. So if we compare 4, 4 is also in these subsequences. 4 comma 5 is also in this subsequence here. When you talk about 4 and 9, here it is 9 and 4. I told you that just order may be differences. Order may be changed, like 4 and 9 is there. 9, 4 and 9 element are present, but the order might be different. Since in this question we are talking about the count of the subsequences which satisfy the given conditions, like minimum and maximum. So we need to access the maximum and minimum element. Anyhow, we need the maximum and minimum element accesses. So if I get subsequences, so our suppose subsequences 4 and 9 and or 9 and 4, it doesn't matter the sequence order but element order, but I need the maximum and minimum element of this two subsequences. I can also find the maximum and minimum element from this also and this also, which gives the same value. If I take 4, 5 and 9, here 9, 4 and 5, if we find the maximum element and minimum element from this element and maximum and minimum element from this element, these subsequences, I will get the same value. And it is same for all. When we take 5 and 9, here 9 and 5 will be there. I missed that 9 and 5 is there. I missed that something. There is 9 and 5 also, because when I take 9 and I can take this 5 also, which is order is different but the numbers are exactly same. So when we find the minimum and maximum element, we get same. So the problem statement, since say minimum and maximum, we are getting the minimum and maximum element. I hope it is clear. Now that's why we are sorting the element, because sorting helps us to finding the minimum and maximum element in easy way. Let us see the given example. Here we are given 3, 5, 6, 7 and target equal to 9. So first step is to sorting the element. I hope you understand I hope you understood why I am sorting first. I am sorting because I get the minimum and maximum value very easily. So the minimum value at the left and the maximum value at the right. So the first thing I have to do is I have to calculate the sum of the minimum and maximum. And if the sum is less than or equal to, if the sum is less than or equal to the target element which is given here 9, then I will increase the count by 1. It means that our subsequence 3, 5, 6, and 7 will be in our uh, as per our given questions. Means it will satisfying the given conditions. But here when I add this 7 plus 3, it 10, which is greater than 9. So it is not accepted. So what I will do, I will remove this largest element and decrease my right pointer by 1. Now again I will do 6 plus 3, it will give 6 plus 3 is 9, which is lesser than or equal to target, which is exactly same as the target. It means that now our subsequence can be 3, 5, and 6. Subsequence element has 3, 5, and 6 value, where the maximum value is 6 and the minimum value is 3. In that case, it is satisfying the condition. So anything element between this 3 and 5 is obviously also satisfying these conditions. I mean to say that if 6 plus 3 is less than or equal to 9, then it is obvious that the element which is lesser than this largest value also sums to the less than equal to target. I hope you understood. Uh, then it means that for 3 as a smallest element, when I take 3 as a smallest element, we have two possibilities. For 5, either I can take this or I will not take. For 6, I will either take or I will not take. So for if there are two elements, there are four possibilities. So we have two possibilities, which is 4. 2 can be found by using L minus R, sorry, R minus L. So our R is here at 6, whose value is equal to 2, R value equal to 2, and left value equal to 0. So when I do R minus 0, 2 minus 0, I will get 2 element. I should get 2 element. It means every time I have to do power of 2 power R minus L. So this will increase the count. Similarly, if I calculated the count for this 3 1, I have to increase my left pointer by 1 and check for the fifth one. And if it is not satisfying the given condition, sum of the lowest plus largest, smallest plus largest is less than or equal to target. If it is not satisfying, I am doing decreasing the right pointer by 1. So again, when I came here, my left pointer will be at 5 and the right pointer at will 6. 6 plus 5 equal to 11, which is greater than equal to target. It means I have to decrease my right pointer and right pointer will be at 5. Again, I will do 5 plus 5 equal to 10. Now our right pointer will be here at 3 pointer, at 3 element. In that case, I get left pointer is greater than right pointer. So I will exit and return the count whatever I have done. So the steps are very easy. What I think I have to do here is sorting the array. As I told, why I am sorting, because it is not, we are just calculating the count. We are not calculating the exactly, we are not printing the subsequences. We just need somehow, we just need the minimum and maximum value of these subsequences. That's why sorting helps us to find the minimum and maximum subsequence. And then we are using, after counting, I am running while loop where I am checking the condition if norms of the left plus norms of that right pointer, norms of left plus right pointer is less than or equal to target or not. If it is, I'm doing that count plus equal to power of 2 comma r minus l. I told you why I am using r minus l. For I have two possibilities like 6 and 5, and everyone has a two possibility. Either I can take in the subsequence or not. So that's why I'm taking 2 power r minus l. R minus l shows there are r minus 1 element. And as when we code here, now this will throw runtime error. So for that, we will use pre-computational power. Like I have to pre-compute this pre-compute power. So for that, what I will do, I will take power, I will take vector int power, and size will be n. And for every power of initial is power of 0 equal to 1. Power of 0 equal to 1. I mean to say here, like I mean to say here, I will take an array of size n where I will store the power. So initially power is 1 and the power of 2. 2 power 1 is 2 into this previous element, which will gives 2, and again 2 into this previous element, 2 into 2 is 4. Every time I am multiplying by 2 with the previous element. Again 4 into 2 gives 8. So what I am doing, I am just taking the equal to n minus 1. I hope it is clear. And finally, this is for if the condition is satisfying. If it is not satisfying, if it is not satisfying, it means else condition, I will do r minus minus, and finally I will return count. So these things are inside while loop, this else and if else condition inside while loop, and every time I will do the same task, rechecking the target value is less than or equal to not. If it is, and also what we are doing here, we are replacing the left pointer. I hope it is clear. First thing we are doing here is sorting, then checking the algorithm, checking the target conditions, which is left minimum plus maximum is less than or equal to target or not. If it is, then we are increasing the count by power of 2 comma r minus l. And for this, if it throws a runtime error, in that case I have to use a pre-compute, and we are also taking a modulo as given in the questions. Now let us see how we can solve this problem. First of all, I will take int n equal to num stretch size, and first thing I have to do is I have to sort these numbers. So I will use inbuilt function sort num stretch begin and num stretch end. It will take big of n log n, which is quite better than previous one. It takes big of n log n, and then I have to find the minimum and maximum element, which I will take low equal to 0 and right equal to n minus 1, n minus 1. And also I am taking count, which will store the count of subsequences which satisfy the given conditions. So initially count is 0, then I have to run this loop while left is less than or equal to right, and every time I am asking whether the sum of left and right, the minimum and maximum sum, so nums of left plus nums of right pointer is less than or equal to target or not. If it is satisfying, what I am doing, I am increasing the count equal to count plus power of r minus l. I hope this will throw an runtime error because it takes more time. Power of 2 comma r minus l, it will throw runtime error. So for that we have to pre-compute, and here it is also shown that we have to take modulo instance. So I will do it later. First of all, let us do using this only, and every time I am increasing left pointer. As we have seen that in case of 3 we are first calculating the all the subsequence for the 3, and then for 5 and so on. That's why I am increasing L plus plus, and if it is not satisfying the given condition, it means I have to check for next largest element which is smaller than the previous. So I have to remove the previous largest and check for the another possible cases. And finally, I am returning count. This is quite easy. Let us run this. It will be accepted, but it will not submit all the test case. Sorry, here I have to use a semicolon. Let us run. It is accepted, but it will not submit. Yeah, it is accepted, but when we submit it, it will throw runtime error at this point. Yeah, it is showing runtime error. For that, what I have to do is I have to first pre-compute. For that, I have to use vector int power, and the size is n. And I have to initially the power of 0 is power 0, 2 power 0 equal to 1 only, and I will use for int I equal to 1, I is less than n, I plus plus, and every time power of I equal to 2 into power of I plus I minus 1. I hope it is clear. It is very easy to understand, like we just storing the power of each, like 2 power 0, 2 power 1, 2 power 3 and so on up to n. And if I store here, I can easily fetch the given power exactly here, like a power of r minus l, means 2 power r minus l. So also we have to take care of modulo. every time I am taking modulo here, int mod equal to 10 power 9 plus 7, which is the highest prime number. It will we have to do modulo with this number so that it will not throw runtime error. So I have to take modulo with mod, the highest number, and here also I have to take modulo. Now when I submit this, it should submit. Let us see. Why? Okay, here vector r is there. Sorry for that. It should run now. Yeah, it is accepted now. Thank you.